Let us continue this project to plot the graph in part B. In this part, you are required to plot a function given to you, and you don't have to make it flexible, just plot exactly the function given to you, which means if there is some constant or coefficient or multiplier, just use the same value exactly. You don't have to ask the user to key in a different coefficient or constant in order to create different graph. You don't have to do that. So what you need here is actually a button just to trigger the calculation of the values of x and y. You need the values of x and y to plot the graph, and just say something about the button. So perhaps we drag in the label first. So we say click the button to plot the graph of, in this case I want to do 1 over sine x. Since we have a lot of space here, why not we make it bigger? And you don't have to rename the label 1 in this case, because we are not going to refer to this label. This label just serve as a means to explain what the button do. We are not going to refer to it or reading and writing to it in our code. 20 is too much. 12. Okay, then drag the button. The button has to be renamed because this is a trigger. Graph calculate button. And the caption is under text calculate. Again, make it bigger. The font can be bigger too. That is it. Save it and test. So we get it, but nothing happened yet because we have not defined the event handler for the button. Then we want to calculate the graph. Double click. So we get the event handler. Let me structure this thing first. Alright. So in order to list the values of y at different values of x, and then we want to save it in a file, we can use one of the family of printf function. For GUI program, the regular printf will not work because this is not console. Printf will only print on console, but we still can print into file. So there is one function in printf family of function, which is fprintf, that you learn in chapter 6. We are going to use that to save the values of x and y. But to use fprintf, you need to include stdio.h. Then, before you proceed into plotting the graph, you should predict how the graph looks like. All the equation that we give to you is something that you should have known or should be able to predict or sketch how the graph should look like. In this case, for 1 over sine x, the graph should look like this. Roughly. So, in order to plot this, I need to calculate for many value of x, which means repeating the same calculation. This means it is a for loop. And inside, we produce the values of x that we want to calculate the y for. So it has to be double because we want to step as small as possible, so it cannot be integer. So double x. In this case, for 1 over sine x, I can start from negative. Let's say I want to start with negative 720 degree. Later we need to convert this to radian. Then the condition is as long as x is less than or equal to 720, the other side of the graph. Then the stepping is, let's say I want to step with 0.01 degree. This will give a lot of values and my graph should be smooth enough. Then we have to convert x to radian. X rad is x divided by 180 multiplied by pi. You have to use the pi that we can obtain from the .NET, which is max : pi. And we need to declare x radian. Then we need to calculate the function of what? Function of this 1 over sine x. So y, the y-axis is equal to 1 divided by, to get the max function, you just use max : sine. That one. Sine of what? Sine of x radian. Then y need to be declared also. We can declare in one line like this. Then the values of x and y are there. So we need to use printf. Printf. Printing what? Printing the value of y and the value of x. Sorry. %f and another %f. New line. It is the value of y and value of x. And you see, this is printf, but we are using fprintf. We need to give the pointer to the file where we want to save the values of y and x. Let's say I have the pointer as with name the file. Then we need to declare the file as file pointer. Then we need to open the file, fopen. We need to give the file name and the mode. The file name, let's say my graph, and I want to save as .txt, make it easy. Then the mode is you want to save it, you want to open the file to be written, so it is W. If you want to open the file to be read, then it is string of R. But we want to open the file as an output, so it is to be written. And this one is assigned to the file. Then we have to close the file at the end, like that. We call fclose and give the file, the pointer to the file to be closed, the one that we just opened. Alright, so that is it. Let us save. Then let us rebuild to see if we have any error. Looks like okay. Then let's run. Okay, click it. it doesn't seem to do anything, but actually you are supposed to get a file named mygraph.txt. You can name with your own name inside the folder where we have our exe. So this is my folder. This is the exe. It doesn't seem to create the file, so I'm thinking that we have to run this one separately. We cannot run in Visual Studio. Run this here, then click on Graph tab and then calculate. Now we have the mygraph.txt. Close it, open it. You can see there are a lot of entry, and you obviously need to do some modification of this data once we open it in Excel afterward. So it's up to you to decide how small you want to step, because the smaller you step, the smoother your graph will be, but you will get more lines in your text file. And you also need to decide the range of your x value. Some graph, for example, log graph, giving negative value to x will not give any meaning, or you will get complex value of y. So you have to decide what is the range of your value. Do not follow this one. Before we log output from our code just now, let us sort of anticipate what is the kind of curve that we should get from our graph. Because the graph is 1 over sine x. Sine x is sinusoid. It's a wave across x-axis, which means sometimes it is positive, sometimes it is negative, and a few times the graph of sine x will cross 0. The point where at the x value where the graph cross 0, the 1 over sine x definitely will be infinity. So we should have infinity where the graph of sine x is 0, because 1 over 0 is infinity. And we should have the graph at the negative side also, and of course the positive side of y-axis. The reason is because sometimes the sinusoid of sine x is above x, and sometimes it is below x. If it is negative below x, then 1 over negative is also negative. If it is positive, 1 over positive is also positive. So we should expect a graph of this kind. You should do that for your project also, because at the level of first year undergraduate, you should be able to make such anticipation. Now let us open the text graph with Excel so that we can make a graph out of it. We can start with a blank Excel, and then we browse to open the text file. Go to your project folder. You need to find the text file. This is it. Now Excel will need to convert the text file into Excel format. So it will ask a few questions so that the conversion is correct. Are the values actually printed with fixed width? This is true if I put something like %3f, %10f in my sprintf just now, but I didn't do that. So the value that I put in the text file is not fixed width, but it's delimited by the space that I put in the fprintf statement. So it is delimited values by some delimiter. We will tell that later. Next. And for my case, as I said just now, when I print the value using fprintf, I put a space between the value of x and y. So the delimiter between x and y is a space, not a tab. Okay, next, then finish. So actually, I should have printed x in the first column and y in the second column, but I made a mistake here. But anyway, it's easy to swap the column in Excel. That's it. Then let me select the two column, and then to create the graph, just click insert and then choose for a suitable chart. In this case, it is XY scatter, and choose the line graph. Click OK. So you see, I don't get this type of graph. The reason is because when the value is infinity or negative infinity, that extreme value will suppress or push the small value at this point to look like they are touching the x-axis. So what we need to do is we need to remove the extreme value so that we can see the curve that we want to see. So I can remove this chart. Then what we need to do is we need to sort the column according to the y value and remove anything perhaps more than 10 or less than negative 10. Sorry, back column B, largest to smallest. And don't forget, I need to do this twice because I need to remove the extreme negative values also. Alright, then when we delete it, we delete just the y, don't delete the x. If we delete the x, then the graph will be sort of jumping when it's not supposed to jump. From this point, it will jump. There will be a line connecting the two discontinuity, which is not right. That will happen if you remove the x where you remove the y value. So let me remove this until I see a value around 10, perhaps until this one. All right. Then we need to sort again, but now smallest to largest. So I can see the extreme negative value. Then after that, we sort them according to x-axis again, or in this case is column A. Then we can insert the graph again. That is it. This is how the graph should look like. So it's easy to get the correct graph. Your job now is to make this look better, change the chart title and everything so that it looks nicer. This finished your part B for your project.